So we're getting ready for the first of the 3 tests in Chapter 4. You won't have a big long test at the end, but it will all be put together on your final exam or midterm exam. So the first part asks us to determine if the polynomial, or if each of these is a polynomial, and if so, find the degree. And remember that a polynomial has to have integer exponents, positive integer exponents, and we can't have roots or negatives. So in this first one, this is the same thing as x to the negative 2. So since this is not a positive integer, this is not a polynomial. This actually would be a polynomial. All of these are exponents that are positive. So let's just write yes instead of polynomial. And this is degree 2. We can't have any kind of square root functions because technically a square root function is the same as a fraction exponent. So we're not going to have fraction exponents, so no, this is not a polynomial. This is a polynomial, and this is a constant, and the degree is 0. Not a polynomial because of the fraction exponent, and yes, this is a polynomial, and it's linear, and it's degree 1. All right. Then we're sketching general transformations of these. So this is a 5th degree polynomial, and I know that this is going to take on the shape of a chair function. It's going to be shifted 3 units to the right, and it's going to be a little bit fatter. So moving over 3 units to the right, I'm going to kind of come up here, and around here it's going to be a little bit fatter than normal. We're not looking for specific points except for maybe the starting point where we shifted it over. This one is a even function, so it's going to take on the shape of a parabola. I know it's going to point down because it's negative, and it's going to be shifted down 1. So my vertex would be down 1, and it would be negative, like that. In this next problem, it's asking us to answer the following questions for this long polynomial, and it's nice that it is factored for us. So it's asking for the x-intercepts. So if I look at each factor, I'm going to have an x-intercept at -1, an x-intercept at 3, an x-intercept at -4, and an x-intercept at 2. Okay. The y-intercept is going to happen when x is 0. So in this function, if I plug in 0 for each of these x's, I will find the y-intercept. It's going to be a huge number. If I plug in 0, I'm going to have 1 squared. If I plug in 0, I'm going to have -3 to the 3rd power. If I plug in 0 here, I'm going to have 4. 0 plus 4 is 4 to the 4th power. And then if I plug in 0 here, I'm going to have -2 to the 1st power. And I went ahead and did all these calculations. Basically, I'm going to have -3 to the 3rd power is -27, times 4 to the 4th power is 64, times -2. And I know this is going to be a positive value, and if I multiply those all together, I'm going to get 13824, 13,824. Okay. Just a hint, it's not going to fit on our graph down here. Part C asks us if the graph will touch or cross at each x-intercept. So in this case, we need to look at the multiplicity. And the multiplicity for -1 is 2. So multiplicity 2. The multiplicity for that 0 in this one is going to be 3. Multiplicity of this factor is 4. And the multiplicity of 2 is just 1. So the factors that have an odd multiplicity, it's just going to go through the x-intercept. Okay, so for x equals 3 and x equals 2, it's going to go through the x-axis, and that's because of the odd multiplicity. For the factors of -1 and -4, it's going to bounce, and that's because of the even multiplicity. Part D asks us to find the end behavior of the behavior of the graph near each of the x-intercepts. So this is where we can make a sign chart, and if I just sketch the x-intercepts on a x-axis or on a number line, -4, -1, 2, and 3. If I plug in values into my function for something smaller than -1, so let's pick a number smaller, that would be -5. So I'm just going to say, okay, if x is -5, what happens when I plug that into each of these factors? So -5 plus 1 is -4, so that negative is squared, and that's going to be positive. -5 minus 3 would be -8. To the third power is going to be negative. A negative to the third power is negative. -5 plus 4 is -1. To the fourth power is positive. And -5 minus 2, let's try that again. I'm going to go back here. -5 plus 4 is -1. To the fourth power is positive. -5 minus 2 is negative, so that's going to be negative. So now I know this part right here is negative. Something between -1 and -4, let's try -2. Again, we're just looking for the sign values. So -2 plus 1 is negative, squared, I get a positive. -2 minus 3 is negative, and a negative to the third power is negative. -2 plus 4 is +2, and to the fourth power, a positive is still positive. And -2 minus 2, that would be -4, so this factor here is negative. So this value right here is negative. Between -1 and 2, let's pick a 0. If I plug in 0, 0 plus 1 is 1. Square it, I get a +1, so that's positive. 0 minus 3 is negative, so negative to the third power is still negative. 0 plus 4 is positive, to the fourth power is positive, and 0 minus 2 is negative, and that would remain negative. So this part is also negative. Then I'm going to pick a number between 2 and 3. Okay, so I don't have an integer, so let's pick 2.5. Again, we're just looking for the signs. So 2.5 minus 1 is a positive. Square it, you get a positive. 2.5 minus 3 is a negative, and a negative to the third power is negative. 2.5 plus 4 is positive. Positive to the fourth power is positive. And 2.5 minus 2 is positive 1/2, so this is positive. So I'm looking here, and you know what? I'm going to go back here and reevaluate things, because here I have 2 negatives, and you're thinking, Miss Gurney, that should be positive. 2 negatives here. Negative times a negative is a positive. Here I have a negative times a negative is a positive, but here I just have 1 negative, so this is going to be negative right here. Sorry about that. And then a number greater than 3 is 4. If I plug in 4, 4 plus 1 is positive, squared is positive. 4 minus 3 is positive, to the third power is positive. 4 plus 4 is positive, to the fourth power is positive, and 4 minus 2 is positive. So all of those are positive. So it looks like the only place our graph is going to be negative is in this area here between 2 and 3. And then it says to take all of this information and let's sketch a graph. Well, I don't like this graph paper that they gave us. It's really hard to see our points, so I'm just going to make another graph over here. Okay. And I'm going to basically plot the same things. I have -4, -1, here's 2 and 3. Okay, so I know these are my zeros. I also know I didn't determine what degree it is. So to look at the end behavior, let's look at the degree. If I count up how many x's are being multiplied in this, I'm going to have x squared. And this one I'm going to have x to the third power, x cubed. This one I'm going to have x to the fourth power. And then this last factor, I just have 1x. So if I count how many x's are being multiplied, 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. And because this is even, I'm going to have both of my ends going up to positive infinity, both ends of the function, and it's positive because my coefficient is also positive, so it's going to go up. So if I take that, I know that here it's going up like this, and over here it's going up like this. All right, so as it comes down to 4, okay, if I look at -4 and the multiplicity of -4, that's even, so it's going to turn up, and then it's going to turn back down and hit -1. -1 also is an even multiplicity, so it's going to turn back up, and it's going to go way up to our y-intercept, which is really high, and this is going to be y equals 13,824. Okay, really high on that one. Then it's going to turn back down, and it's going to get to 2. And if I look at what happens at 2, the factor 2 is an odd multiplicity, so it's going to go through it, and then it's going to turn back up and go through 3. And if I look at 3, 3 is also an odd multiplicity. So it's going to kind of have this shape here. I don't know how far this maximum, this local maximum, will go here, and I don't know how far it's going to go down here. It could go a lot further, but I do know that this one goes really high. All right, so that's a general sketch of this graph. If we look at the next one, same kind of problem. Here I'm looking at a much more simple polynomial, and the x-intercepts, if I look at this part, if x squared is 0, x is going to be 0. And if x is 0 here, I'm sorry, if I set this equal to 0, x is going to be 3. And the y-intercept, okay, I mentioned this in class, anytime you have an x-intercept of 0, I'm going to kind of bring this down here, it's going to go through the origin. So because it goes through the origin, it also has a y-intercept of 0. And because it's a function, it only has one y-intercept. So if x is a y-intercept, then your y-intercept automatically has to be, if x equals 0 is a y-intercept, sorry, if x-intercept is 0, then the y-intercept also has to be 0. That was a better way to say that. Does the graph touch or cross at each intercept? So again, we're going to look at the multiplicity. Of 0, the multiplicity is 2 because it's x squared. And at this one, the multiplicity is 1. So at x equals 0, it's going to bounce because of the even multiplicity. My lighting is horrible. Lots of shadows. At x equals 3, it's going to go through the x-axis because of the odd multiplicity. Okay. We can also find the degree. That's going to help us with the end behavior. So the degree is 2 times, or x squared times x is x to the third power. So this is degree of 3. And because it's odd, we're going to have a graph that, and by the way, it is positive, that goes down this way and is going to do something in here, and then it's going to go up at the end. So if I find the behavior of the graph near the intercepts, let's make that sign chart. I just have a 0 and a 3. So a number less than 0 is -1. So if I test -1, if I square -1, I get a positive, and a -1 minus 3 is a negative number. So at -1, this is going to be negative. A number between 0 and 3, let's pick 2. If I put in 2, 2 squared is 4, that's positive, and 2 minus 3 is negative, so this is also going to be negative. And after 3, let's pick 5. If I plug in 5, 5 squared is 25, that's positive, and 5 minus 3 is positive 2. So this area is going to be positive. Again, I don't like that graph, so I'm making my own. Here it is. And what we said before is it's going to start on the left side, going down towards -infinity. When it comes up and hits 0, 0 has an even multiplicity, so it's going to stay negative because it's going to bounce. Okay. Then it's going to turn around and it's going to hit our x-intercept at 3. Because 3 is an odd multiplicity, it's going to continue to go up. All right, so this is what this is telling us. On our sign chart, anything less than 0 is negative. Anything between 0 and 3 is also negative. Sorry, couldn't see all of that. And anything to the right of 3 or anything greater than 3 is going to be positive. All right, so that's what that graph will look like. That one was a little bit easier. And then we have some division problems. So we have long division, and here I'm going to rewrite this just because I write bigger than this small font. So I have x plus 1, and here I can insert any zeros if I need to. But if I check my exponents, I start with 3, and then I have 2, 1, 0. So I don't have to add any place holding zeros. And I can just do x to the third plus 3x squared minus x plus 3. So taking the first term of the number I'm dividing by, I would multiply that by x squared to get x to the third. And then I multiply both terms by x squared. So I get x to the third plus x squared. I now am subtracting all of these. So x squared times 1 is x squared. I just wanted to double check on that. So I'm subtracting, those cancel, and then I have 3 minus 1 is 2, x squared. I'll bring down my x minus x, and then I say how many times does x multiply to be 2x squared, and that would be plus 2x. Multiply 2x squared, and then I have 2x times 1 is plus 2x. Subtract, and I'm subtracting the entire quantity. So here I have 1, negative 1, minus 2 is negative 3 with an x, and I bring down my plus 3, and then I have x times negative 3 is negative 3x, and if I multiply both terms, negative 3 times 1 is negative 3, and if I subtract, I'm going to have nothing, and then 3 minus negative 3 is 6. Okay, don't be fooled because you have 3's here that they're going to cancel. Remember, we're doing subtraction. All right, so my answer for this one would be x squared plus 2x minus 3 with a remainder of 6, and that would be plus 6 over the number I'm dividing by, x plus 1. All right, the next one. If I look at the numbers inside the division sign, I have a 5, I'm missing a 4 and a 3 and a 1, x, those powers of x. So as I rewrite this, I have x to the 5th, I have no x to the 4ths, and no x to the 3rds. I do have 3x squared, I have no x's, and then I have minus 10. Okay, so we have to hold those place values. So I multiply x squared by x to the 3rd power, and then I get x to the 5th here, and then here I get minus x to the 3rd power. So I'm going to line those up. Minus 1x to the 3rd power. So I'm subtracting now. The x to the 5ths cancel. I don't have any x to the 4ths, but I do have 0 minus negative 1 x to the 3rd. So that's positive 1 x to the 3rd. Okay, so then I can bring down plus 3x squared plus 0x minus 10. And I'm just bringing all of this down because here I'm skipping a term, I'm missing an x, so it looks like I'm lining up with every other exponent. So x squared times x would be x to the third, so I'm going to add x and multiply. So I have 1x to the third, and x times -1 is -1x, and I'm subtracting. Here with my 3x squared, I have nothing here. So this is 3x squared minus 0, which is 3x squared. And then I have 0 minus -1, so that's plus 1x, and then a minus 10. X squared times 3 is 3x squared. So I multiply 3x squared, and then 3 times -1 is -3. I'm subtracting. I have 1x minus nothing is 1x, and -10 minus -3 is -7. So on this one, my answer will be x to the third plus x plus 3 with a remainder of, and I'm adding x minus 7 over x squared minus 1. Okay, so here is the answer for these two. And lastly, we'll go to synthetic division. First thing I want to do is identify my 0. So my 0 here is -1, which will be the number that I'm going to use for my multiplication. And also here, I'm noticing I have an x to the 5th power, so I'm missing lots of terms. So for my coefficient, for my x to the 5th, I have a 1, but x to the 4th is 0, x to the 3rd is 0, x squared is 0, x to the 1st is 0, and x to the 0, or my constant, is 1. All right, so let's see how that looks. So the first number I automatically just bring down, and here I'm going to multiply. So -1 times 1 is -1, and I'm going to add down, so I get -1. -1 times -1 is +1. I add down, I get +1. -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is +1. Add down, I get 1. And -1 times 1 is -1. Add down, I get 0. All right, so if we think about what we have here, this is my remainder. Okay, so remainder 0. And this is my constant term, or x to the 0. This is x to the 1st, x squared, x to the 3rd, and x to the 4th. And just double checking that you have these in the correct spot. It's always going to be, the exponent in our answer is always going to be 1 less than what we start with in our problem. So my answer here is 1 x to the 4th minus 1 x to the 3rd plus 1 x squared minus x to the 1st and plus 1, and then remainder 0, and I don't have to write that. Last one, synthetic division. My 0 here is 3. Okay, if I set that equal to 0, I get 3. So 3 is my number I'm using for this. If I check my exponents, I have 3, 2, 1, and 0. So I don't have any spaces to add anything here. So if I put my coefficients in, the x third term coefficient is 3, x squared is 2, x to the first is -1, then +1. First number I bring down, and now I'm going to multiply. 3 times 3 is 9. Add down, I get 11. 3 times 11 is 33. Add down, I get 32. 3 times 32 is 96. Add down, I get 97. Okay, so now this is my remainder. This is my constant, x to the first, and x squared. So my answer here would be x squared plus 11x plus 32 plus my remainder is 97 over the number I'm dividing by is x minus 3. Okay, so these are the types of problems you're going to see on your test tomorrow.